Hello, and welcome to Lesson 3 of B.3, the Cancer Unit. I'm Nicole Bettis, an OpenSciEd facilitator and former high school biology teacher. In this video, I will give an overview of Lesson 3 and wrap up with some tips and tricks. The key to this lesson is the cell game, and I hope after watching this video, you feel prepared to take it on. Before we get too far ahead, let's briefly recap how we got here. During Lesson 2, we figured out that cancer cells look different from non-cancer cells and can form a tumor that can invade surrounding tissues and make us sick. So now that we have a better idea of what cancer is, we're wondering how cancer happens. How do non-cancer cells become cancerous? Now let's dive into Lesson 3. Lesson 3 takes 3 class periods. It involves playing 2 rounds of the cell game, looking at reference data about the cell cycle, and then sorting cards with the phases of mitosis. The 30 minutes of material preparation listed here is to prepare materials for the cell game and the mitosis card sort. If your cell game is already prepared, then 30 minutes is probably sufficient. However, if you need to print and prepare the cell game, then it will take much longer than 30 minutes. In the tips and tricks section at the end of this video, I will go over a few things you can do to save time. Finally, students do not need to use their individual devices unless you would like them to access a digital copy of the cell data. There are 4 big parts in this lesson. Let's take a look at what is happening in each. In the first part of Lesson 3, students play round 1 of the cell game. After the game, students work in their groups or alone to complete a table that they can use during the building understandings discussion that follows. The purpose of the discussion is to help students figure out that cells go through different phases, ending with mitosis when one cell forms 2 new cells, and that these different phases are regulated by P53 to ensure that a cell doesn't move to the next phase until it has everything it needs. Students know from Lesson 1 that P53 seems to play a role in cancer, so now they're wondering about the connection between cancer and the cell cycle. So in the second part of Lesson 3, students play round 2 of the cell game. Similar to round 1, students complete questions at the end of the game to help them make sense of what happened. Then they participate in a building understandings discussion to help them figure out that when P53 fails to prevent a cell from moving to the next phase before it has everything it needs, a cancer cell might be formed at the end of mitosis. At the end of the cell game, students are left wanting to know more about how the new cancer cells that are formed differ from the starting non-cancer cell. In the third part of Lesson 3, the class looks at and discusses 2 slides with data about the cell cycle. Then students work with a partner to put cards with different phases of mitosis in order. From these activities, they figure out that a cell grows in size and the genetic material doubles during the first phases of the cell cycle, and that mitosis is the part of the cell cycle where a cell goes through a series of organized steps that allow it to divide into 2 new cells with identical genetic material. At the end of this part, they're still wondering about the cancer cells from round 2 of the cell game and how those cells differ from the starting non-cancer cell. So finally, the lesson wraps up with a quick activity where students place chips on a model handout that shows cell division during round 1 of the cell game and another showing cell division during round 2. This helps students figure out that a cancer cell does not have identical chromosomes at the end of cell division. After this, we update our initial class consensus model from Lesson 1, and students fill out their progress trackers. To summarize, over the course of this 3-day lesson, students played 2 rounds of the cell game to figure out that cell division happens through a series of phases that are regulated by P53, and that 2 identical cells are formed at the end of mitosis. They also figure out that when P53 fails to regulate cell division, a non-cancer cell can divide to form a cancer cell, which will not be identical due to chromosomal differences. Let's take a moment to dig into a few key moments in Lesson 3. The first key moment in Lesson 3 is playing the cell game. Students play the cell game in groups. Each student has a game piece that they move around the board and 1 non-cancer cell at the beginning. The game is actually quite simple to play. On your turn, you move forward 1 space and roll 4 dice to collect nutrients, proteins, and organelles. If you land on a checkpoint space, then you follow the instructions on the appropriate checkpoint card. As you move around the board, you will move through the phases of the cell cycle. When you make it to the finish, you collect a new non-cancer cell chip. The next key moment in Lesson 3 is when we make sense of the cell game. After students play the game, they complete the table on their handout where they describe what happened in each phase and what it might represent in a cell. In the first half of the discussion, the class goes through each of the phases and checkpoints, and students can make changes to the responses in their tables if they need to. In the second half of the discussion, the class tries to make sense of the M phase. At this point, students will have figured out that cells go through specific steps during the M phase, which is why they had to roll a specific number to move to the next space. But they likely don't know much else about what happens during these specific steps. This will be further investigated on day 3. Another key moment happens when we make sense of round 2 of the cell game. During round 2, students draw a cellular chance card each time they land on a light-colored box. Some of the cellular chance cards allow them to move around the board more quickly, even passing through checkpoints without the necessary materials. This will result in students collecting a red cancer cell chip at the finish instead of a blue cell chip. This time, when students finish playing the game, they answer questions at the end of their handout that they discuss with their group and then as a class. Students figure out that when P53 doesn't work properly, a cell can continue through the cell cycle without everything it needs. And when this happens, the cell can divide and form a cancer cell. After making sense of the cell game, we ask students to evaluate the cell game as a model. This helps us navigate to looking at data to answer some of our questions. So we look at an image of a cell at different periods of time and a graph of the relative amount of genetic material. From this, they figure out that a cell grows and doubles the amount of genetic material before it divides. The final key moment is a quick and simple activity to make sure that students understand the outcome of cell division, that cell division can lead to cancer, and that cancer cells have differences in their chromosomes when compared to non-cancer cells. They will investigate these differences in more detail in lessons 5 and 6. By the end of lesson 3, students have figured out a lot about what cancer is and how it happens, but we haven't addressed why different types of cancers are more common than others, or why older or taller people have an increased risk of cancer. We want them to be thinking about whether there might be something going on during the cell cycle of certain types of cells or in cells of older and taller people, because that will be our focus in lesson 4. Now that you have a better understanding of lesson 3, I want to provide you with a few tips and tricks. First, let's talk about the cell game. If you have a kit from one of the providers, then the game should be included. Check ahead of time to see if you need to punch out or label cell chips, as this can take a while. If you don't have a kit from one of the providers and need to make the cell game, then you will want a colored printer for the game board and the cell sticker sheets. If you want to save time and ink, the game can be played with unlabeled red and blue chips, or there's a digital version on the Facebook page that a teacher created and shared. To find it, use the search feature and search Digital Cell Game, then scroll to the post from February 5th, 2025. Here are some tips for playing the game. First, set a timer and stick to it. The first time I played this game with my classes, I wanted to make sure they all had a chance to make it around the board. We ended up playing the game over 3 or 4 class periods, and they were over it by the end. It's okay if not all students finish, because they'll find out what happened from those who did. Second, there is a lot of dice rolling. Groups with fewer students work better, so there's less time waiting for others to roll the dice. You can also use digital dice to speed up the dice rolling process. Third, instead of having students turn over the appropriate checkpoint card when they land on the space, just keep the checkpoint cards turned over and place them near the space. Fourth, have students keep their cell chips on the game board in the designated circle so they don't play with them or lose them. Finally, because students will go around the board more often in round 2, they will run out of checkboxes on their scorecard. You can use a plastic sheet protector and markers that can wipe off for each cell, or you can add extra rows of boxes before you print the scorecards. My students used different colors each time and made new marks on top of old marks, which worked, but their scorecards got pretty messy. Finally, have fun with the game. My favorite is in round 2 when some students think they're winning because they have more chips than everybody else. When it's pointed out that red chips are cancer cells, they realize that maybe they're actually losing. It's fun discussing who the actual winner of this game would be. Now, let's talk about personal glossary and poster management. Students encounter a lot of words in this lesson. Many of the words they encounter are from middle school, but it's okay if they don't remember them. If students ask about organelles, nutrients, or proteins while playing the cell game, it's fine to tell them what these things are, or to say these are just the things a cell needs to take in or make as it grows. In Lesson 6, students will encounter specific organelles involved in protein synthesis as they learn more about proteins. Similarly, if students ask about chromosomes, cell membrane, nucleus, and spindle fiber while sorting the mitosis cards, then it's fine to tell them what these things are. Students will continue to gain an understanding of chromosomes throughout the unit, especially as they use pipe cleaners as chromosomes when they model inheritance in Lesson 8. There are 2 words that we do co-construct in this unit. After discussing round 1 of the cell game, we add cell cycle to our personal glossaries. And after doing the mitosis card sort, we add mitosis. Fortunately, there isn't much for poster management for Lesson 3. At the end of the lesson on day 3, you will need the initial class consensus model from Lesson 1, and students will need their progress trackers. You won't be creating any new posters in this lesson. While I know the cell game can seem intimidating at first, I hope after watching this video and following some of the tips and tricks that it goes well for you and your students. In the next video, I will be talking about my favorite simulation in this unit, so I hope you check it out. Good luck, have fun, and I'll see you next time.